All right, so to finish this section up, like I just mentioned, we're going to talk about these figures called circles. We haven't talked about circles yet. We've been talking about polygons, straight-sided closed figures. We've dealt with the size of the angle or the sums of the angles of those and how to find the perimeter and how to find the area. So I want to be able to do the analogous thing with these things called circles. But before we do that, I'm going to tell you what a circle is. So a circle is all the points in a plane the same distance, or this, I guess I should say the same distance, there's two words there, from a reference point called the center. Now, the center is not part of the circle. It is the reference point that gives us the circle. And so that distance right here, this same distance that all the points on the edge of a circle are, this is called the radius of the circle. Okay, these might be terms you're familiar with. I'm sure that at some point in your math past, whether you enjoyed it or not, you've dealt with the idea of a circle and what it is. So we're going to talk about two things, the same two things we've talked about with straight line figures. We're going to talk about the perimeter and the area. Now, for a circle, the circumference, that is the fancy math word for the perimeter, meaning the distance around the outside of a circle. Okay, and so the way you find the circumference of a circle, notated C, is it's equal to 2 times this number pi. We're going to learn just a touch more about pi in our last unit in this class. Pi is called an irrational number, and what that means is it can't be represented by a fraction. Okay, it's a decimal that never ends and never repeats. Okay, so it's 2 times pi times the radius of the circle. The area, the inside region of a circle, area is that number pi that is derived from and kind of unique to circles, and it's pi times the radius, but this time squared, so radius times itself. So we're just going to go through a few examples of this and how to notate answers. And if you have any questions, please bring them up. That's what we're all here for. But here's my example. My example is we're going to find the area and the circumference of this circle. We're going to write it as an exact answer. We're also going to write it as an approximation. Okay. When you go through your homework in my math lab, most of the circle problems will ask you for both. So let's go ahead and do this. We're going to start with the circumference. The circumference, the distance around, if I was to put a fence around this, is 2 times pi times r. Now, the first thing that we're going to do is we're going to write the exact answer. The way this might be phrased is to write it in terms of pi. Actually, this simplifies your job. To write the exact answer, I think, is a lot easier, or not really easier, but it's less to have to write down. So when I go to do the exact answer, what I'm going to do is I'm going to say 2 times pi, and then what is the value of the radius of this circle that we're looking at here in this problem? 6. Yeah, it's just the distance from the center to the outside. Remember, the center is the reference point right here. And so that distance from that reference point to any point on the edge of the circle, in this case, is 6 centimeters. So I'm just going to write the number 6 right there. So if you are asked for the exact answer, what you're going to do now is you're going to say, okay, that's 6 times 2, that's 12 times pi. And there you go, you're done. That's the exact answer. That's the answer in terms of pi. Okay, that's one of the ways that when you go to do your homework, you're going to be asked to write down the answer. The other way, the other thing you're going to be asked for is an approximation. You'll be told what to round to in order to do this, and all you're going to do is you're going to put in some value for pi. Normally, you're going to do one of two things. Just follow your instructions. It really shouldn't matter, but most of your scientific calculators have a button for pi. So if you have a calculator with a pi button, I would just say use it. So on this TI-30X is what they sell in our bookstore. So you possibly have one of these. If you have a different calculator and you don't know where the pi button is, show me after class, we'll find it. But all I'm going to do is I'm going to do 12 times, and then on this calculator, the pi button is right above the caret that we use for power. So I'm going to hit pi. And this is going to give me the approximation. And I'm just going to round this to the tenths spot. And so that's 37.699111 and some other numbers. I'm going to round it to the tenths, and it's going to be 37.7. In both cases, I forgot to write down my units, so let's do that. Since the circumference is a distance around the outside, the units are just going to be centimeters. If you don't have a pi button, a great approximation is just to say pi is approximately 3.1415, and that should give you enough significant figures to round your answer appropriately. All right, we're going to come back to this problem. We'll do the area in just a minute, but before we do that, we're going to flip the page to the top. And at the top of the next page is another circle. And I would like you to find the circumference and write it in terms of pi, and then write down the approximation and round the approximation to the tenths place. Just to give everybody a nudge, I'm kind of assuming a little bit here, and I apologize in case that's not true of you. What is it called when I give you the distance from one edge of the circle to the other edge? Anyone know that? It's called the diameter. So if you did not know that, that's okay. That's why I'm here. It's called the diameter. And in this case, the diameter given is 8 yards. So when you're plugging and chugging now into that circumference formula we just had, what's the radius of this circle going to be? 4. Okay, the diameter goes all the way across. That's what that line there is referring to. It's telling you you've been given the diameter, so the radius is going to be 4. Okay, so I'll give you a little bit more time. Just wanted to make sure we were clear on that notation. All right, so our circumference is equal to 2 times pi times r. You just told me a moment ago that the radius is 4 yards of this, so that's 2 times pi times 4 yards. So that means the exact answer, the answer in terms of pi, is 2 times 4, or 8 pi yards. So far, so good? Questions, comments, concerns at all? All right, well then, now I'm just going to go to my calculator. I'm going to say, okay, 8 pi, that seems wonderful. So 8 times pi is going to give me, and this is going to be 25.1327 and a lot of other numbers. I asked you to round to the 10th. That's 25.1. So the approximation is going to be 25.1 yards. Okay. All right, so I'm going to flip back. Same sort of thing with the area. I don't think once you know the formulas, which in this case you do need to know those formulas. Once you know those, it's plug and chug. And so the area here is pi r squared. Again, we're going to give the exact answer first, and then we're going to give the approximation. So the exact answer of this problem is going to be pi. The radius, as we already said, this one was 6. So pi times 6 squared. And so my exact answer is going to be 36 pi. Now remember, area units are always square units because that's a region. It's like carpeting. And so if the original radius was centimeters, that is going to be centimeters squared. And then once again, the approximation, I'm going to take 36, I'm going to multiply it by pi, and that is going to give me 113 and a whole bunch of numbers. And when I round to the 10th, that's going to give me 113.1 centimeters squared. And there we go. We all right with that? Did I do anything mysterious? Please, there's no bad questions. Okay, I want you leaving here feeling really confident. Okay, then flip the page back to that other example we were doing and find the area of that circle and do it exactly and then approximation. All right, so on this problem, the area of a circle is pi r squared. That's the thing that you need to know. Once you remember that area formula, then it's just plug and chug. So the area of this circle is going to be pi times, in this case, the radius was 4, so 4 squared. So the exact answer is 16 pi. The units are yards, so for area, that's yards squared. Anybody get something different we need to talk about? We okay? All right, the approximation, 16 times pi is going to give me 50.2654 and some other numbers. And so rounded to the 10th, that's 50.3 yard squared. All right, so exercise 9 is just kind of a little application problem just to practice finding the areas of circles. So exercise 9 says, okay, which one's the better deal? You're going to Domino's and there's two specials. There's a large 16-inch diameter pizza for $15 or a medium 8-inch diameter for $7.50. Okay, so you're going to tell me which one's the better deal. Now, if you don't know how to figure out which one's the better deal, you at least know how to figure out the area of both of these pizzas. So do that. And if you don't know what to do after that, pause and I will help you with the rest of determining which one's the better value. And just round to the 10th like we've been doing. Follow the instructions in my math lab, whatever they're telling you to do. All right, so here's what we got on this problem right here, exercise 9. First thing I'm going to do in my quest to figure out which is the better value for me is I'm first going to find the area. So for the large pizza, that means I'm going to find the area that is going to be pi times r squared. So that's pi times, what's the radius of the large pizza? 8 inches, so 8 squared. So I'm just going to throw all that into my calculator since I'm doing a problem with all approximations. It's not super necessary to keep it in terms of pi. So I've got 64 times pi there. 8 times 8 is 64. And so that's 201.1. So that's 201.1, and the units are inches squared. So the surface area of my pizza, where all the cheese and sausage and all the good stuff is going to be, is 201.1 inches squared. Now for the medium, okay, similarly, the area is going to be pi r squared, and I'm pretty sure if I asked you, you would tell me that the radius of that one is going to be 4. It's going to be half the diameter, so 4 squared. And so when I throw that into the calculator, I've got 16 times pi, and that is going to be 50.3 inches squared. All right, so the question is, and maybe you didn't know this part, and that's okay. That's why we're here. We're doing the problem together. So now when you see it on your homework, you'll be able to replicate it and then learn. What we just need to figure out is what is the price per unit. If you do the grocery shopping in your household like I do, you go to Publix, you go to Walmart. When you look on the little tag that's on the shelf, most of the tags, like for instance, you're shopping, let's say for soda, and you want to compare, is it better off to buy a 12-pack of cans or a 2-liter bottle or some other size, or which brand is going to be the best? On the little tag at the grocery store, it'll give you a cost per ounce for something like soda. That's called a unit cost. It's telling you, if you break it down, what is going to be the least expensive option of all the different shaped containers and brands. So what we're going to do is we're just going to figure out the cost for each unit. Okay, so I'm just going to write that right here, the cost for each unit. So in the case of the pizza, what I'm going to do is I'm going to figure out how much am I paying for square inch of each pizza. This is going to determine for me if I have enough money for either, which one's the best value. Okay, which one am I paying less for overall? So the large one I'm going to is cost $15. So what I'm going to do is I'm going to say, okay, that's $15 for, and what I get is 201.1 square inches. First time through, I'm just going to round this to the 10th. If we need to go back and round it more, if it's that close, then we can. And so when I take my 15 and I divide by 201.1, I get that cost 0.0745. So I'm just going to round. I'm not going to round to the 10th. I'm going to round to the 3rd decimal place since since the number is so small. So I've got 0.07, and then I'll round 0.075. Okay, so that is 0.075. That is about 7.5 cents per square inch for that large pizza. Let's do the same thing for the medium then. The medium is $7.50 for a 50.3 square inch pizza. And so when I put that into the calculator, it's $7.50 divided by 50.3, and that turns out to be 0.149 when I round to the 3rd decimal place. So $1.149 per square inch. So which one's the better deal? Which one costs less if that's what I'm concerned about? The large one does. Okay, so which one's the better deal? I'm just going to circle. This one would be the better deal because you're paying less for each square inch of pizza. Now, I know the pizza costs more, right? But it's bigger is basically what's going on. And the cost doesn't stay proportional in that case. And that's generally, when you go to the grocery store, what happens. And that's why places like Costco and BJ's and Sam's Club were originally popular, is when you buy something in big bulk, you're paying less per ounce usually, but you should always do the math because sometimes they try to get you and it's not really cheaper. So anyway, little life advice. All right, exercise 10 and 11, they're basically the same problem. So what I'm going to do is I'm going to do exercise 10. I've got a video as part of your homework. You can do exercise 11 and then check your answer on the video. But both of these, like I said, are basically the same problem. What I want you to do, and before you do it, you're going to describe the process, is for this figure right here, I want to know if I've got this parallelogram and then I have a hole punch and I punch out this hole in it, I want to know what the area left over is. That's what we're being asked to do here. So describe for me, what do you think the process is? What am I going to do? Perfect. So in case you didn't hear that, what I was told is we're going to find the area of the parallelogram because that's the bigger figure. Then we're going to find the area of the circle. And since in this case the circle's been punched out, I'm going to subtract those values. Okay, so go ahead and do that. Round to the 10th, give it your best shot, and let's see how it goes. All right, so I'm just going to go through the busy work. At any point, if you have a question, something's going on, let me know. So first thing I'm going to do is I'm going to find the area of the parallelogram. So area, I'm going to use a little subscript P there for the area of the parallelogram. Remind me, this was last time we were together. How do you find the area of a parallelogram? Base times height. And I think one of those dimensions is super obvious. The base is 10 feet on this. The other one, you kind of got to do a little clever figuring. What's the height of that parallelogram? How'd you get 4? That's exactly right. Right, the way this thing is drawn, we are led to believe that the height of the parallelogram is the same as the diameter of the circle. And so that means that the height is going to be 4 feet. Great. If you didn't see that, that's okay. That's why we do these problems, is to give you an experience so that you can not be surprised the next time you see it. So 10 times 4, that is 40 square feet for the parallelogram. Then I'm going to do the same thing for the circle, which we've just started talking about. So the area, I'm going to use a little subscript C. And the area of a circle is pi r squared. So in this case, that's pi times 2 squared. Or in other words, 4 pi. And so when I go into my calculator, 4 times pi is equal to 12.566. So rounded to the 10th is 12.6 feet squared. So we're just asked to find the area of the shaded region. So what's left over? And we already determined we're going to subtract. So when I take the 40 square feet minus the 12.6 square feet, then what that is going to give me, it looks like that's going to be 40 minus 12.6. That is equal to 27.4 square feet. All right, so the last problem, it's not going to take you too long, so I'm not trying to burden you with extra homework. When you go to your Canvas shell after class, I will post the video that I have of this last problem. It's essentially the same thing, so you go ahead and work out that problem, check the video, you can scroll to the end of it, and you can determine if your answer is right or wrong, and if you're wrong, then you can go back and watch the video, see where you went astray.